first lesson is an introduction to the Pythagorean Theorem. Our essential question, how can algebraic concepts be applied in geometry? Our I can use the Pythagorean Theorem to determine whether a triangle is a right triangle. I can use the Pythagorean Theorem to find a missing side measurement of a right triangle. The Pythagorean Theorem is used to explain the relationship between the sides of a right triangle. Sorry about that. So let's look at a right triangle and talk about those sides. They have specific names and it helps us to input numbers into the actual theorem. A right triangle, remember, has one 90-degree angle. This theorem only works for right triangles. The two legs are the sides that connect to make that right triangle. So they're the ones that are your vertical and horizontal sides. So those are usually labeled with A and B. Those go into your theorem in place of A and B. The hypotenuse is that diagonal side. It's always opposite from the right angle. And something very important to remember, it's always the longest side. So out of the three, the hypotenuse will be the longest. And it's C in our theorem. And, very important, the Pythagorean Theorem itself. A squared plus B squared equals C squared. So those are actually exponents of 2. A squared plus B squared equals C squared. Okay, so we're going to look at our first example. We're going to use the Pythagorean Theorem to determine whether a triangle is a right triangle. And it would have to fall into a Pythagorean triple is what it, sometimes it's called. So we're going to look at this particular triangle. We don't know whether it's a right triangle, but we do know all three side measurements. So we can plug it into our theorem to see if it comes up true. If it comes up true, then yes, it will be a right triangle. If it doesn't, then it's not. Sometimes they really look like a right triangle, but they just aren't. They're slightly off. So let's first talk about which of these measurements will be our legs, A and B, and which will be that hypotenuse, that C, the longest side. So I always go ahead and out of the three, pick that longest side. That diagonal is always going to be the hypotenuse and go in place of C. So I'm going to go ahead and say that C is going to get replaced with 5. Then the other two sides are your legs. They're the vertical and horizontal that meet to make that angle that looks like it could possibly be a right angle. So it doesn't matter which one of these you make A or B, as long as your two legs are A and B. Now what you're going to do is plug these values into your equation, use order of operations, and simplify it. So we're going to put 4 in for A, it's 4 squared, plus 3, so that's B squared, equals C squared, which we'll replace with a 5. So make sure that you find the exponents first before you add. They're on the right side. 4 squared is 16, 3 squared is 9, 5 squared is 25. Then we're going to add this side. 16 plus 9 is 25. So since my two sides are equal, this is a right triangle. So I can go ahead and put that little right angle symbol in there. So since when I plug in those values, my two sides are equal, then it is true this is a right triangle. If the two sides became unequal, then it wouldn't be a right triangle. Okay, now we're going to use the Pythagorean Theorem to determine whether this particular triangle is a right triangle. And in this situation, they're not drawing it for you, however, they are giving you the three side measurements. We have 10 meters, 13 meters, and 17 meters. You don't have to see the triangle to determine which one's A, which one's B, and which one's C. Because like I said, I always go for the longest one first. The longest one is always going to be that hypotenuse. Okay? And then we're left with 10 and 13. Doesn't matter which one you make A, which one you make B, as long as those two are your legs. So I'm going to plug this into our formula. 10 squared plus 13 squared equals 17 squared. So we're going to go ahead and do the math. 10 squared, of course, we know to be 100. 13 squared, just going to check the math, is 169. And 17 squared is going to give us 289. Now we're going to add our two sides, or our two side or legs squared. 100 plus 169 is 269. That does not equal our c squared, which is 289. So it's not equal, which means this is not a right triangle. So notice that you don't really need the picture of the triangle because you automatically know that that bigger side is C. Then the other two are going to be your A and B. All right. Our last example, we're going to look at using the Pythagorean theorem to find a missing side measurement. So in this particular triangle here, we know 6 inches is this horizontal side. We know 7 inches is the diagonal. We want to find the value of x, which is this vertical side. Round your answer to the 10th place because we are going to be dealing with square root, so you will need to round it. Okay, so what you need to decide is what is A, what is B, and what is C. The diagonal, the side that's opposite from the right angle, is always going to be your hypotenuse. So we know that 7 has to go in place of C. Now left over are those two horizontal and vertical sides that make up that right angle. Those are going to be your legs. Again, doesn't matter which one is A and which one is B as long as they are A and B. So we're going to plug these into our formula. Okay. Now we need to get x by itself, so we're solving the equation for x. So let's go ahead and get rid of these exponents. 6 squared is 36. X squared, we're going to keep it x squared. 7 squared is 49. So we're going to begin to get x by itself. So I'm going to subtract 36 on both sides. So x squared is equal to 13. Okay? Now, we don't want to know what x squared is. We want to know what x is. So since x is being squared, we need to undo that square by finding the square root. But remember, whatever you do to one side, you must do to the other. So we're going to be finding the square root of both sides. When you find the square root of x squared, that gives us x. You're just kind of canceling out that power of 2. Now we're going to find the square root of 13, and we're going to round it to the nearest 10th place. We get 3.60, so we'll keep it at approximately 3.6. Now we're going to replace our x with 3.6 inches. We're going to look at our picture and make sure that makes sense. One thing you want to make sure that this side is not longer than the hypotenuse. If that happens in your problem, then you need to go back and see where you made your mistake because the two legs are both going to be less than that hypotenuse. But you're going to plug it in, get x by itself, and then you have your solution. We'll do more examples in class.